What is map and how it works? Map is an interface representing a collection of key-value pairs. It allows you to store and retrieve values based on unique key-value pairs. Each key in a map is associated with a corresponding value, and the keys are used to retrieve the values. The map interface is implemented by various classes, such as hash map, tree map, and linked hash map. Each implementation has its own internal mechanisms for storing and retrieving key-value pairs efficiently. Let's talk about the internal workings of HashMap, which is the most commonly used implementation. The HashMap class in Java uses an array of buckets to store the key-value pairs. When you add a key-value pair to a HashMap, the following important points are important to understand in order to keep a good grasp on the internal working of HashMap. It starts with hashing. When you add a key-value pair to a HashMap, the HashMap calculates the key's hash code using the hash code method of the key object. The hash code is an integer value that represents the key. Next is index calculation. The hash code is then used to calculate the index in the underlying array where the key-value pair should be stored. The index calculation involves applying an algorithm that transforms the hash code into a valid index within the array bounds. The other important point to understand is collision handling. In some cases, different keys might have the same hash code or end up with the same index after the index calculation. This situation is known as a collision. HashMap handles collisions by using a linked list at each bucket. If multiple key-value pairs have the same index, they are stored as a linked list of entries in that bucket. Storing the key-value pair is another point to understand. The key-value pair is stored in an entry object, which consists of the key, the corresponding value, and references to the next entry in the linked list. If a collision occurs, the entry is then added to the appropriate bucket in the array. Next is retrieving the value. When you want to retrieve a value associated with a key, HashMap performs the same hashing and index calculation steps to determine the bucket where the key might be stored. If a collision occurs, it iterates through the linked list at that bucket to find the entry with the matching key. And the final one is efficiency. The efficiency of HashMap is achieved through the proper selection of the array size and the use of a hashing algorithm that minimizes collisions. In ideal scenarios with no or minimal collisions, the average time complexity for insertion, retrieval, and deletion operations is constant time. However, in worst-case scenarios with frequent collisions, the time complexity may degrade to linear time. It's worth noting that the internal workings of other map implementations, such as tree map and linked hash map, are different. Tree map uses a binary search tree to store the key-value pairs, maintaining them in sorted order. Linked hash map combines a hash table with a linked list to preserve the insertion or access order of the entries. Understanding the internal workings of HashMap gives you insights into how key-value pairs are stored, how collisions are handled, and how the efficiency of the operations can be affected. This knowledge helps in selecting the appropriate map implementation based on the specific requirements of your application. Now let's look into a code example to understand how a map works in Java. In the example, we create a hash map called studentMap to store student names as keys and their corresponding IDs as values. We add key-value pairs to the map using the put method. Values can be accessed using the get method, and we can update values for keys using the put method again. The remove method is used to remove a key-value pair from the map. The contains key and value methods check if a specific key or value exists in the map. The size method returns the number of key-value pairs in the map. We can iterate over the keys, values, or entries of the map using for each loop or the entry set method. How do you create a map? We can create a map object by calling the appropriate map class constructor. For example, we can create a hash map by calling the hash map constructor. How do you add key-value pairs to a map? We can add key-value pairs to a map by calling its put method. How do you access a value associated with a specific key in a map? We can use its get method to access a value associated with a specific key in a map. How do you check if a map contains a specific key? To check if a map contains a specific key, we can use its contains key method. How do you check if a map contains a specific value? To check if a map contains a specific value, we can use its contains value method. How do you update a value associated with a specific key in a map? To update a value associated with a specific key in a map, we can use its put method. How do you remove a key-value pair from a map? To remove a key-value pair from a map, we can use its remove method. How do you check if a map is empty? To check if a map is empty, we can use its isEmpty method. How do you find the size of a map? To find the size of a map, we can its size method. How do you iterate over the keys of a map? To iterate over the keys of a map, we can use its keySet method. How do you iterate over the values of a map? To iterate over the values of a map, we can use its values method. How do you iterate over the entries of a map? To iterate over the entries of a map, we can use its entry set method. How do you sort a map by its keys? To sort a map by its keys, we can convert it into tree map, which will have all the keys sorted. How do you sort a map by its values? First, we can use the entry set method to build a list of entries. Then we can use collections.sort method by passing the list and the comparator as lambda function to sort the map.entryList based on values. Now as map.entryList is sorted based on values, we can link hash map to build a new map which will be sorted based on its values. How do you merge two maps? To merge two maps, we can use its put_all method. How do you get a default value if a key is not present in a map? To get a default value if a key is not present in a map, we can use its get_default method. How do you compute a value for a key in a map if it is absent? If the key is not already associated with a value or is mapped to null, we can use its computeIfAbsent method. How do you compute a value for a key in a map if it is present? If the value for the specified key is present and non-null, we can use computeIfPresent to compute a new mapping given the key and its current mapped value. How do you get a synchronized map? We can get a synchronized map by calling the synchronized map method of the collections class. How do you create an immutable map in Java? We can use map.of to create immutable or unmodifiable map. We need to pass key and value pairs. The number of key and value pairs that can be passed are from 0 to 10. What are the different implementation classes of map interface? The Java map interface is implemented by several classes in the Java Collections framework. Some commonly used implementation classes of the map interface are HashMap. It is a widely used implementation of the map interface. It provides constant time performance for basic operations such as put and get. It does not guarantee the order of its elements. TreeMap. It is an implementation of a map that maintains the elements in sorted order based on the natural ordering of the keys or a custom comparator. It provides efficient operations for finding the smallest and largest keys. Linked HashMap. It is an implementation of a map that maintains the insertion order of its elements. It provides predictable iteration order, which can be the order in which entries were added. Hashtable. It is a legacy implementation of map that is synchronized, meaning it is thread-safe for concurrent access. However, it has lower performance compared to other implementations. Concurrent hash map. It is a high-performance implementation of map that is designed for concurrent access. It allows multiple threads to access and modify the map concurrently without external synchronization. Enum map. It is a specialized implementation of map where the keys are restricted to be of an enum type. It is highly efficient and provides type safety. These implementation classes provide different characteristics and performance trade-offs, allowing you to choose the one that best suits your requirements.